Testing 1 2 3. Testing 1 2 3. Sorry about the wait, guys. Ready to come back online for a new day of streaming. Yeah, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. It's Friday. That means we're going to be sitting here for a couple hours and doing some programming while I discuss the very, very basics of programming and Python programming. But it's really more of a course about the ideas that go into any kind of computer programming. That's not to say it's Python specific. It's really more just a general type stuff. In this case, we're making a example program that's based on the classic Pokemon games for the original Game Boy. I haven't played any of the newer, newfangled ones. This is a very simple example using the simplest of mechanics from the classic Pokemon. So where are we right now, guys? Well, we talked last time about inheritance, right? We're talking about object-oriented programming. When the series first started off, we did purely functional programming. It was just a very straight down line of simple instructions. We had some, if statements, some else statements. We had even a little bit of elif, and we had some while loops. But it was mostly just very simple, top to bottom kind of programming. Now we've kind of changed our program up quite a bit now. We're using classes more, which is to say that now our program isn't so much running from top to bottom straight down. It's really more like we're defining these classes which have what we call methods attached to them, right? So a lot of this stuff we're doing is happening down here. So basically when you have a class defined, this code does not run right away, right? All this code in here, all these functions, they don't run. They only run when you call them, like any function, right? So we have these classes being defined up here. Lots of stuff is being defined. And it's typical of object-oriented programming, right? You define a lot of things right off the bat. You kind of sort of design your code. You kind of lay it out, right? You lay out how you want things to behave, right? This here as well as our final class. And then here at the bottom, we finally have things that happen in the code, right? The things that actually execute all this stuff. So we have a simple assignment here. We're assigning a name, Pokemon 1, to a new Pokemon object that we made. Right? That's defined right here, this kind of class. And then we have Pokemon 2 is also assigned. It's a name that's being assigned to another Pokemon. And then finally, we have a method that runs down here. We've got Pokemon 1, his move dict. Right? We talked about dictionaries last time, about how dictionaries are like, they're called maps, right? They're also called maps because they map one kind of data to another kind of data. In this case, we're mapping a string, which is the name of a move, to the actual move object itself, which in this case would be a tackle, right? So we have this move, we have this name, which is a string, it's tackle, and then strings are textual data. And in this dictionary, it's associated with the actual move. It's an instance of tackle. I think we talked about instances, right? We talked about how you have a class which defines how a certain kind of object will work. But then you have the instance, which is the object itself, right? So think of it like a mold, right? Tackle's like a mold in this case. And then you actually use this mold to make a move. You kind of use it to spit out a tackle. RuneScape, what's up, Faust? If you guys are new to the channel, you might not realize my man Faust is the single greatest RuneScape player of all time. He's received multiple awards in his career for amazing RuneScape play. In my mind, anyway. Oh yeah, so we have this, so basically we're using this dictionary here to access the object, which is a move, at tackle, right? So tackle is kind of like a slot in the dictionary. And whatever move is here at tackle, we're going to use its method, use on. Right? And we're going to use an argument there, Pokemon 2. So this is the most complex line. We talked last time about we have a couple complex things in this code, right? This is all pretty simple. If you guys were watching the previous episodes, you know about functions and stuff like that. This is all pretty straightforward here. Except we have this little block here, which is a pretty complex little block. Right? For being 4 lines, it's pretty complex. And then we have this line of code right here, which is also pretty complex. So we talked in depth last time about these 4 lines and how they work. Quite simply, what it does is it takes this list of classes, right? Tackle and comb hair, they're not objects, they're just classes, right? They aren't themselves a thing, right? They're just like molds, basically. And we're taking this list of classes, and we're iterating through it, right? So when you have a for loop, see it says for, right? For in. This is a statement that makes a loop based on a list. So what for does is it goes through every item in a list and it does something to it. Right? So we're saying, hey, for every object, right, you can name it whatever you want. For every, we're calling it Pokemon move class. For every Pokemon move class, right, inside this move list, do this stuff. And really what it does here is it takes every class from this list and then it makes an instance of it. Right? So what it does is it uses that mold and makes an object from it. Right? So for everything in this list, it makes an object from that mold. For every mold in this list, it makes an object from it. And then it puts that new move it created, that new instance, into this dictionary, and it uses its name as the key. So we talked about dictionaries before. They associate one type of data, which is a key, with another type of data, which is called a value. You have a key and you have a value. And in this dictionary, we're using the key is the name of the move. So we have tackle, and then we have it associated with the actual move tackle. What's up, Zonzo? How you doing, dude? Foss got the golden gnome several times. The golden gnome. So we're getting a little bit too advanced for me. Yeah, we're going a little bit more in depth. We started off very simple. In fact, I think that as the series goes on, we're going to do a loop, right? We're going to loop back around. We're going to start off very, very simple and then gradually build on that knowledge until we've reached a point that I'm comfortable with for like beginners. We're going to go back to where it was simple again. But right now we're in a spot, we're kind of like an intermediate level of programming, right? We're being so early in our dev, day 5, we're getting some kind of complex stuff. We're talking about classes and instances, right? We're instantiating stuff, which means to make an instance of. That's the verb form. If you instantiate a class, you're making an instance of it. And we're using dictionaries. They're kind of complex, right? Dictionaries, they associate data. So again, right here we have the instantiation being done. Right? This is the line where the instantiation happens right here. We make a new object called a new move. It's a new move. We're making a new move, and we're calling it new move. We're using this class we got from the list to make that move. And then we're adding it to the dictionary at its own name, right? So we're saying our move dictionary, add in a new object at this new move's name. So if it's for tackle, its name would be tackle, right? That's why we can access it right here this way. Right? We can just put in the name of the move and get it from the dictionary. And we're making that spot in the dictionary equal the new move. So this line right here at the very bottom, what it means is, we've talked about this last time, it's kind of a complex line, so let's review it. What we're trying to say right here in this last line is, access whatever data is at tackle in this Pokemon's move dictionary, right? So whatever data is at tackle, right? It just so happens, let's just put some hyphens in there, that the data at tackle is an instance of class tackle, right? So we used this class tackle to make an instance, right? So we made a tackle, basically. We used the tackle mold to make a tackle. And then we put that data in the spot called tackle in the dictionary. So it's very simple to access later. Right. Then we use a method that's attached to that instance, right? Use on. So we talked before about how the period in Python and most programming languages is like an apostrophe S in English. It implies ownership. So we're saying, on this line we're going to say, the Pokemon's move dict tackle, right? The data at tackle, z apostrophe S right here. Let's put in apostrophe S's for you guys, right? Right, there you go. So in English, that's what it would look like, right? You got some apostrophe S's. That's how it would look like in English. So we're saying, Pokemon 1's move dict tackles use on method, right? So we're using the use on method of whatever, this object is, Pokemon 1's move dict tackle. So we go up here to look at use on for tackle. This is what we're calling right here. We're calling the use on method of a tackle object. And that just runs the code for, doing a tackle to another Pokemon. So let's actually run this code and see what it looks like. It's going to be very simple. And all we really have going on here is a couple lines of assignment. Again, in our original code for our Pokemon example here, we've been working on for about a week now. This is our 5th day. In the original code for it, it was very, it was very, what we call functional. It was functionally programmed, which is to say that it ran from top to bottom in a linear fashion. Now we're being much more object-oriented. So before we had like a big list of instructions that just ran. We just ran the whole thing from top to bottom. But in this case, what we've done is we've defined a bunch of objects and given them behaviors. Right? So think of it more like, instead of it being a list of instructions, think of it like we're doing arts and crafts, right? We're making things, we're designing things, right? Instead of it being like a list of, like a to-do list, now we're actually making objects, and each of those objects has a thing that it can do, right? The object itself has properties, which we call attributes, which are like variables that are attached. Like, for instance, our Pokemon down here, he's got a monster type, He's got an elemental type. He has an HP, an attack stat, and defense stat. So every object we make has attributes, and then it has things that it can do, which are methods, which are basically they're just functions, but they're attached to this type of object. For instance, we have use on here. As you can see, it's defined just like any other function, but it's indented inward into this class. So because it's attached to this class, it's called a method. That's really the only difference between a function and a method, is that a method's attached to a class. They're otherwise exactly the same. And a method always gets a self as the first argument, so that way you can access the object that it's attached to. Okay, so yeah, so previously we had a big long list of instructions. Now all we have is 3 lines of instructions, right? All we have here is just we define 2 Pokemon, and then we use one of those Pokemon's moves. Very simple. Let's actually see how this runs now. Okay, so all that happens when you run this code is that Cyndaquil tackled Squirtle. Squirtle took 4 damage, Squirtle has 64 HP remaining, and Tackle has 9 PP remaining. If you guys are new to Pokemon, you might not realize that PP is we're not talking about number 1, we're talking about power points, which are like ammo. Every move in Pokemon has ammo for that move. It's like a gun. Every move is its own gun. It's got a certain number of ammo. If it runs out of ammo, you can't use it anymore. Okay, so now we've kind of refreshed ourselves a little bit what's going on here. Let's start adding to this code. Let's make it a little bit more interesting. So the first thing I want to do today is I want to well, let's talk before I do that. Let's talk about inheritance again. So we talked before about making a class, right? When you make a class, first of all, you usually want to define a init, right? You define this function here. It's called underscore underscore init underscore underscore. Now, any method or function or attribute or variable, whatever, in Python that starts with and ends with 2 underscores, what that means is that it's a magical thing. It's whatever it is, it's magical, which means that it's used in ways that other methods or attributes or whatever are not used. In this case, you have a init, right? You don't actually, it has these underscores, you don't really call a init. You don't say, here's my instance init. You don't say like, you would never say, Pokemon 1, then run the init method, right? You never say, right, Pokemon 1 dot init, in arguments, right? You would never do that because that's not the way init's meant to be used. Init is meant to be used when you instantiate an object. So whenever you do this right here, whenever you give the class name, like this, you give the class name, and then you open parentheses, and you define that the arguments for that class, and it spits out an object. What that's doing here is it's using the mold of Pokemon to make a Pokemon. But what it's actually doing is it's calling the init method. You don't see that, though. It doesn't say init right here. You don't say, like, Pokemon.init, right? You don't do that because it's a magical function. It's called automatically in this circumstance. And that's true of a lot of things in Python. You'll have things like, there's a certain attribute called, name, right? There's a lot, and there's a certain thing, there's one called, like, something like, I don't know, is there a key, something like that? There's a lot of these, what they call dunderscores, double underscore on both sides, magical objects in Python. In this case, whenever you define a class, you usually want to define a init, which means this is the function that runs when you instantiate that class. So in Pokemon's case, when you define that class, you need to supply a monster type, an elemental type, and a few different stats, right? And we use those things to make the Pokemon here. Now up here we have this Pokemon move. It's got, some attributes of its own. It's got some methods as well, like print startup and use on. But we're talking about inheritance here today, which is an object-oriented programming principle, which means to say that we're not actually going to instantiate Pokemon move per se. We're not going to make any kind of objects based on this mold. Instead, we're making other molds based on this mold. In fact, we have this tackle here, right? As you can see, when we define Pokemon move, we say class Pokemon move. Right? So it's just a very simple class. It's not based on anything. It's just its own thing. However, when we define tackle, we say class tackle, parentheses, Pokemon move. So what we're saying here is we're saying make a new class called tackle, but don't just make it totally from scratch. Make it, first of all, based on Pokemon move. So right away, if none of this shit got defined, if none of this ever happened, I'm just gonna fucking, just gonna literally just, get rid of all that and put in JavaScript's special keyword pass. Pass just means don't do anything. Not in JavaScript, excuse me, in Python. It means don't do anything. If we just did this, right? Class tackle Pokemon move pass. What we've already done is we've made a tackle that is the same class as Pokemon move. It inherits everything from Pokemon. It inherits init, it inherits print startup, it inherits, use on, it inherits everything from tackle. Excuse me, from Pokemon move. So right now tackle already works because it already has Pokemon move which already works. However, we're doing more than that. Right? We're doing more than just inheriting Pokemon move. In fact, usually when you inherit something, you usually want to extend that class. You want to override some things in that class. And when I say override, I mean you take a method from your parent class, in this case Pokemon move, and you name a method on your new class the exact same thing. Right, so as you can see here, Pokemon move already has an init. Right, it already has an init. However, we're overriding init by creating an init down here as well. Right, so we're kind of, although Pokemon move comes packaged with its own init, we are making one just for tackle. What's up, Starkey? How you doing, dude? This idea of overriding also ties into the use of this special function built into Python called super. Right, super is built into Python. You can always use it. You don't have to import anything. And what super does is it points back to the parent class. So when we run init here on tackle, which is overriding init on our parent, we're saying, hey, whenever you run init, actually just run the parent's init. Right? So why did we override it in the first place? Right? We're just going to run our parent's init. Why you just get rid of this? Right? We already have an init, right? We already have an init. Why even override it then? Well, because we're actually going to require less arguments than our parent does. So our parent init requires an owner, a move name, a max PP, and an elemental type. Right? It needs all those things. But our tackle's init only needs an owner. That's because every tackle has the same move name. Every tackle has the same max PP, and every tackle has the same elemental type. So we just, when we init tackle, we just need one thing, an owner. And then we say, when you run this code, when you run init, actually run the parent's init, but supply it these things automatically. The move name, right? The maximum PP, and the move type. So when you define a tackle, you give it an owner, and then the tackle says, okay, well, you gave me the owner, thank you. I'm going to supply the rest of the things to my parent automatically. So tackle supplies all the other data automatically to the parent object, right, by running super. And super means use my parent's version of. Right? Use my parent's version of init. Right? Also, we're overriding useOn. Right? Now, in the most basic of Pokemon moves, useOn, all it does is it uses this print startup method. Right? So by default, print startup just says, this Pokemon used this move on this other Pokemon. Right? That's all that it does by default. And then the useOn method just does that same thing. It just prints it out. It just calls it and prints out with the target. In fact, if we look at our comb hair here, comb hair is a very, very simple method. A very, very simple Pokemon move. Right? It doesn't actually override a lot of stuff. It does its own thing. But tackle overrides a lot of stuff. In fact, it overrides useOn quite extensively. So by default, useOn just prints a message off, right? But our tackle does a lot of shit, man. First of all, it checks if it has any PP left. And if it doesn't, it gives you an error message, right? No PP remaining. And then it prints off a message about how, so-and-so's getting tackled. Then finally, it calculates some damage and applies that damage. I'm sorry, I didn't mean to shrink that. Then it calculates and applies the damage to the target, right? And lowers the opponent's health. And then it prints off how much damage was done and how much PP is remaining. Right? So it's pretty complex compared to our original useOn here. useOn really just prints a message, but tackle's useOn does damage, and that requires a little bit of calculation. Right? That's why it's the most complex method in our code so far, is tackle's useOn. So basically, here's why you would want to inherit. Well, there's a few reasons. For one thing, it saves you code. It saves you lines of code, because every move has these attributes, right? Every move has an owner and a move name and a PP and all that good stuff. Every move is the same way in that respect. And so we can save some lines of code by just having all that be replaced with this line, right? I mean, we could just literally do this the other. We could actually just do it, the long way. We could say we could give all the arguments to tackle, for instance, and then just do self.owner equals whatever, self.movename for every move we do. But that's kind of redundant, right? Because they all have the same stats. So just have it be delegated to a parent. Have them all do the same thing. But here's the other importance of using classes, guys, and using inheritance. And that is that it helps you conceptually understand your own code, right? Like we could, for instance, have tackle, have a method called, do tackle, right? You could say, do tackle and then whatever. And then comb hair could have one called, do comb hair, right? something like that, right? But the problem with this is that because they are not using the same universal language, the same grammar, the same names for the functions, then we can't do cute things like this. Let me show you. All right, so look at this line down here. It's Pokemon 1, move, dict, tackle, use on Pokemon 2, right? So this means, do a tackle, basically. That just means do a tackle. However, we could actually comb our hair, or use tail whip, or, use flamethrower, or whatever else you can do, headbutt, whatever, all these Pokemon moves. We can use all these moves once we have them programmed into the game, simply by replacing this string. I'm sorry, I had the Windows key there. Right. By replacing this string, we could do any of our moves, right? Like headbutt, right? But what's interesting about that is that we can only do that because they all have the same name for this method, right? Use on. No matter what move it is, it has this use on function, which means use the move, right? And because they're all sharing that same design, that makes it very simple to swap them in and out. That's exactly why you want to use classes. That's why object-oriented programming is so powerful compared to functional programming. Because we have these data types, these moves, that all have these same functions and the same attributes. You can easily swap them in and out for each other. That's exactly why you use classes. Because they're very easily, they're all made from the same mold, right? So they all have these same properties, and you can treat them all the same, but they do different stuff. And that really makes your program much more functional. I'm sorry, Zanzu. You're still not following, yeah. Well, let's go and look at our Pokemon Day 1 code. All right, back when things were simple. Let's actually open this with, if I open this with a new instance of idle, I'm not sure how this works. I think it might replace my other one. Oh, that's fine. Okay, it looks decent. Okay. So here's our day 1 example, right? All we really did in our first day was we just defined some Pokemon stats, right? And we printed some shit off. Now, there was no classes back then. It was just a very linear sequence of instructions, right? We assigned some variables, and then we printed some shit off. Very, very simple. So from top to bottom. But that's because back then, we didn't have, like, you see this Pikachu up here? We have this Pikachu, right? And he's got health points, and he's got attack power. But he is not a Pikachu. It's just 3 loose variables. It's just that as the programmer, we have to understand that that's kind of like a Pikachu. We got 3 loose variables here. But the difference now is that instead of having a list of instructions, we are creating this thing, this class, this object that we think of as a Pikachu, right? And he has all these attributes about himself, and he can do different things. So instead of just having it be a linear list of instructions, now we're thinking of things as real-life objects. We can actually create these objects, and just like a real-life object, they have things about them and things they can do. What's up, Blake? Yeah, we're programming today, dude. We're talking about programming and how it works. Stuff. Complicated stuff. Okay, so let's see here. So we talked about inheritance, right? We talked about how Tackle inherits Pokemon Move and why it inherits Pokemon Move. It inherits Pokemon Move so that all these Pokemon moves can kind of be based on the same mold. We can just swap them in and out for each other. So you can easily replace a Tackle with a Comb Hair, with a Headbutt, with a Flamethrower, that kind of thing. Let's do the same thing now for Pokemon, right? We have this Pokemon, and it's a class, and we're using it here to define a Cyndaquil and a Squirtle. But instead of doing it this way, why don't we make a Cyndaquil into a class, right? And we can define him much easier then, because just like in real Pokemon, right? There's not just one Cyndaquil. Cyndaquil is a species in Pokemon. It's a species of animal essentially, and just like there are many different dogs, right? There is a species dog, but there are also many different dogs. My dog is not your dog, right? There's different, of course, there's different, there's different breeds of dog as well. But what I mean to say is that there is more than one Cyndaquil. And for that reason, you might need to define Cyndaquil more than once. So if we want to have it, let's say a Cyndaquil fighting a Cyndaquil, right? Let's do that right now. Right, we'll just give him, we're going to have 2 different Cyndaquils here. They're going to be fighting each other now. Instead of doing that, why don't we just make a class for cyndaquils? So this is what we're going to do. We're going to go down here. We're going to say, make a new class, and we're going to call it cyndaquil. But cyndaquil is not just a brand new class like Pokemon is. Cyndaquil is actually based on the class Pokemon. Right? So now right away, but just with these 2 lines of code, 2 very short lines in fact, we have made a new class called cyndaquil, and it already has all the cool things that Pokemon has. Right? Which is to say it has this init method, and it can easily define itself using this method. But let's actually override init. Right? So let's go here and we're going to define a new init just for cyndaquil. And it's going to take, very simply, nothing. It takes nothing, right? Because every cyndaquil, as of now anyway, starts off the same. Right. So we're just going to make a new method, just takes itself, and all that it does is it calls its parents, the Pokemon's init method, and it supplies a monster type, cyndaquil. It supplies an element, fire, and it supplies HP, attack power, and defense, and a list of moves. A list of move classes, I should say. I got a little bit too long there. Let's break the line. There you go. Okay. So now, all we have to do to make a cyndaquil is we can just define, we can just do this. We can just say, hey, Pokemon 1, you're a cyndaquil. Boom. There you go. Now he's a cyndaquil. Right? Because now whenever we run this init function, a init method for cyndaquil, it creates a cyndaquil for us. Now let's do the same thing for, what was the other monster we had? Was it some kind of water type? I don't remember. Let's just call it fucking Machamp. Right. Boom. So it's going to be a Pokemon as well. And it's going to run its parents' super, it's a init function. And it's going to be 1, 2, 3, 4. It's going to be Machamp. It's going to be fighting type, I believe Machamp is. And it's going to have, pretty good health. I mean, it's going to have, let's give it, a huge amount of health. I think Machamp is a 3rd evolution Pokemon, right? It's going to have a shit ton of attack power, a lot of attack power. Like, fucking 20. It's going to have pretty good defense as well. We'll give it, 6. 3 times that of Cyndaquil. And it's going to also have a Tackle and Comb here as its 2 moves. Right, and there you go. So now we have easy ways to define more than one Machamp, more than one Cyndaquil. Right, we can define Cyndaquil very easily, and we can make a whole shit ton of them. Right now we can fucking manufacture Cyndaquils if we wanted to. Right, we just call them. We can have Cyndaquils. We can have Pokemon 4. It could be a Cyndaquil. Right, we can just easily have Pokemon 5. Right, it could be a Machamp. We can easily, now that we have this these molds, we can easily manufacture objects of these classes, or we should call them instances, right? Just spin them out, which is useful, as you can imagine, as your program becomes more complex and you need more of a certain thing. So let's run our code now. I'm sorry, Comb is not defined. I think I need to capitalize the H. Here we go. Oh, I'm sorry, we still have Headbutt here. Let's tack. Okay. There you go. So now Cyndaquil tackles Machamp, right? Took 2 damage, it's all well and good. Now, now that we have more than one Cyndaquil and more than one Machamp, I think that our Pokemon needs a new attribute. Well, we're gonna call it nickname, right? Let's add that right now. Let's add it before the monster type even. No, let's add it right after the monster type. No, let's add it before. It doesn't really matter, but just for our own sake, just to make it more organized for our own sake. We're gonna call it nickname. Right. Boom. So first thing we're gonna do is define our nickname. Self.nickname equals nickname. And now we're going to add another argument to this list here for Cyndaquil. We're going to say, nickname. You have to supply nickname now. And we're going to supply that as the first argument here to our parent as well. Here you go. Likewise for Machamp, just apply nickname. And then we're going to give it this nickname right here. How do you nickname for the other Pokemon then? I'll show you. I'll show you. Okay, so now all Pokemon, this is the Pokemon parent class, they all have nicknames. Every Pokemon has a nickname. Well, that name is Cyndaquil as well. Well, we can give it a nickname right here. We just say Cyndaquil, you know, Vencabot, the Cyndaquil. Right, we can say Machamp, Zanzu, the Machamp. You know, all the Cyndaquil could be named Dickzucker. One of our Cyndaquils could be named, you know, Bloody Angel 67. We have another Machamp here, named Red Panda's Bear. Right, so they have nicknames now. So basically, right up here, when we define the init for a Cyndaquil, why don't you just make them all Cyndaquil? We should do that, you're right. Make them all Cyndaquil. Who wants a Machamp? Fuck Machamp. Right. So in Cyndaquil's init method, it takes one argument, right? We know that methods, they always take self first, so that one doesn't really count. But it takes one real argument, which is nickname. That means that when you make a new Cyndaquil, you give it one argument, which is the Cyndaquil's nickname. Right, so we got one named Vencabot, one named Zanzu, one named Dix, etc., etc., etc. Why the fuck am I the second string Cyndaquil? Get it? String? You fucking twat. Holy shit, dude. Alright, Dix, come on now. Are you having a bad day or what? Relax, homeboy. Settle in. Get comfortable. How you doing, Dix? Well, I hope. Okay, so then when you make a new Cyndaquil, what it does, it supplies to its parent class, you know, Pokemon's in it. It supplies whatever nickname you gave it, as well as these generic, you know, attributes. Every Cyndaquil has them. It's always a Cyndaquil. That's the name of its monster type. It's always a fire type. It always starts off with this much, you know, health and attack power and defense and these moves, basically. Right? But they all have their own little nickname. So, because now we know that every Pokemon has a nickname, why don't we go up here to the default use on. We're going to make this a little bit more complex, the little line of code we're going to write here. Let's say, you know, self.owner.nickname plus the plus self.owner.monster type. Okay. All right, so what am I doing here, do you think? Well, what I'm doing here is I'm saying, instead of saying before, you know, Cyndaquil used move name on other Pokemon, we're saying Vencabot, the Cyndaquil, used move name on so-and-so. Sounds like you're always on top, dude. You bring the bump to the grind. Oh, I don't mind. You're on top. Okay. Coolio. So also here for tackle, we're going to do the same thing, right? We're going to say, you know, self.owner.nickname plus the plus self.owner.monster type. So we're going to say, you know, Vencabot, the Cyndaquil, tackled. You know, I got to fix this up here too. We're going to say, you know, he used move, you know, used the move on target.nickname plus the plus. You know, that we're not just using the monster's type anymore, like Cyndaquil. We're using an actual nickname. What's up, Faust? Every princess needs a king. Doesn't every princess need a prince? Yeah, Let's Go came out last night, right, Dix? Or yeah, today at midnight. I didn't know that until I read that on Twitter today from Rebecca. Said she went out there and got it at midnight launch. I wonder, I hope it's good. I hope it's really, really good. Okay. Same for tackle then, right? We're going to say, you know, so-and-so, the so-and-so, tackled so-and-so, the so-and-so. So self, we're going to say target.nickname plus target.monster type. I really want to talk about f-strings, which will make this all this addition a lot easier, but it's better to kind of zone in on string addition for now as beginners. We'll talk about f-strings later. Are you stupid? Why would it be a prince? Princesses always have daddy issues. Oh, okay, I got you. I got you. All right, so now we're going to say, you know, target.nickname plus the plus target.monster type took some amount of damage, right? Then we're going to say target.nickname plus their monster type has some amount of health remaining. Alright, and we have tackle as much PP left. Okay, cool. So let's just say here for comb hair, we're going to say, self.owner.nickname plus the monster type combs its hair. Gotta break this line though. There you go. Coolio. So let's see how this code has changed now. Now we have nicknames involved. Because now we have nicknames involved. I don't want to tackle Zounzi though. I'll tackle Dix. So Dix is Pokemon 3, not Pokemon 2. There you go. That's why Mr. Krabs calls Pearl his little... I don't know who Pearl is, Dix. I never watched SpongeBob. I know who Mr. Krabs is, kind of. I don't know who the fuck Pearl is. Who the fuck is Pearl? So we say Vencabot... oh, look, I got a typo here. It says Vencabot the Cyndaquil tackled Dick Zucker Cyndaquil. Right, so I missed a the. Let's go up here. Here we go. Plus the plus. There you go. Okay, let's run this again. So Vencabot the Cyndaquil tackled Dick Zucker the Cyndaquil. Dick Zucker the Cyndaquil took 6 damage. Dick Zucker the Cyndaquil has 49 health remaining. We can just kind of a little bit long-winded. We can fix that later though. Fellas, Mr. Krabs is a freak, huh? Fucking whales and shit. He likes those thick girls. Krabs fucked a whale? Let's go, Mr. Krabs. You're beyond that. I'm sorry. You can't tell me who Pearl is. All right. It's just cultural mythology. You're just expected to know that in this culture. Well, he did a hit on Mrs. Puff in one episode. Is she a pufferfish? I hope so. Okay, so now we have nicknames for all these Pokemon, right? So even though we have the Cyndaquil class, which is based on Pokemon, it has one unique attribute, which is that they have a nickname. You can supply that for them now. A pufferfish, yeah, SpongeBob's driving instructor. Oh yeah, there's like a recurring joke in that series, right? Like he's always trying to learn how to drive. He can't ever pass his test. So it kind of makes sense that the instructor would be a recurring character. Okay, so now we have, we talked a little bit more about class extension, inheritance, right? Because now we have these individual Pokemon classes that inherit from Pokemon, right? So all Pokemon have all this shit going on. And there are also individual classes for each type of Pokemon. So now, why don't we add another method to the Pokemon class? That means that all other Pokemon will get this method, right? They can all use the same method. We're gonna say def use move name on target. Now I'm adding this method here. I'm gonna just put pass for now. It doesn't do anything yet. But I'm adding this method here to make this line of code simpler to read, right? It's what's called an API in programming. So basically, programming, you're writing in a human readable language that is then later converted to a computer readable language. So computers basically read it, right? But human beings also have to read it. So for that reason, some of the design decisions you make while programming are not purely for functionality, right? So this line right here, it works. Pokemon 1 dot move dick tackle dot use on the target. But for a human being reading it, it's kind of hard to read, right? Sometimes you just make a function that's purpose is just to make it more readable. So we're adding this use method to the Pokemon, right? To all Pokemon, in fact, because it's the parent class. And what we're going to do with this use method, we're going to say, I have to use self here. It's a method to put self first. There you go. We're going to say self dot move dict move name dot use on target. All right, so when you use this move method, you give it a move name and a target, and then it just simply takes those two things and uses this much longer line of code. It does this one line of code with them. But for that reason now, we can get rid of this line right here, which is very complex, and replace it with something a little bit simpler to read. Pokemon 1 use tackle on Pokemon 3. There you go. right? So this line right here does the same thing as this line, because we're running this method. This method's all it does, right? This method just takes this, these two arguments, and then it makes this line of code out of them. So now we can just get rid of this, and let's run it and see if it works. See, it works exactly the same now, but a little bit easier to read. So basically, when you make an API, what you're doing is you're hiding the complexity behind simpler methods. So we have this complexity here. We're trying to hide that complexity behind something a little bit simpler. What's up, dude? Welcome. Thank you for the follow. This is our friend Darker Cosmotica. Darker Cosmotica. That's a pretty crazy handle. Sounds very hot topic. How you doing, dude? I agree, Dix. I agree. On the one hand, I love the classic Pokemon. That's what I grew up with. And I also think that it makes sense for them to want to reduce, to get new guys into the series, you want to reduce the size of the Pokemon list, right? Reduce the Pokemon count to make it simpler for newbies. But to reduce it that far, it seems a little bit extreme to me. Why not 300? Why not 250? 151, the originals? That seems a little bit small by today's standards. Maybe they'll expand it with DLC, Dix. How about that? Okay, so we've replaced this kind of long-winded line of code with a much simpler method. Pokemon 1, use, tackle. And it's very easy to understand, right? You give it a Pokemon move name, then you give it a target. They could at least have Cyndaquil, I know. 152, how about that? Can add one more. They couldn't add one more. Okay, so there's something I want to accomplish today. Well, one thing I want to do is get the game working again, right? Because right now we have these objects, and we've been testing the objects, but we have no game. As you guys recall, on our second day of programming before, we had a working game, but that was very functional. It wasn't very object-oriented. So we started over from scratch to do this with a bunch of classes, so we could learn how to use them. But now we have to get the game working again. So why don't we do that right now? Let's get the game working like I used to. Darker says, been a dev my whole life and think your explanations are on point, dude. Oh, thank you, Darker. Happy to get your approval. I'm out here doing my damnedest. So let's go back to our day 2. I can actually get rid of this here. Day 1, that wasn't really working that well. Let's go to our day, what was it? Let's try, was it day 3? Let's check day 3. What is day 3? Was this functional? No. So let's go to day 2. Day 2 was our functional code. Back when we were still totally green. Okay. Cyndaquil is greater than Totodile, greater than Chikorita. Chikorita is one of the lamest starters of all time. I love grass types, but Chikorita was super, super lame. So in this code here, again, this is before we had classes, guys. We just simply have a bunch of attributes, a bunch of loose variables here, defining a Cyndaquil and a Squirtle, right? And then what we have this loop here, as you guys remember, right? This loop is a loop that runs, it's like a Pokemon battle. It runs until one of them faints. Right? And it keeps asking the user what move to use. Now, what's really cool about this is that we can already see how our object-oriented code simplifies our old code. Let's look at our old code again here. So in our old code, whenever a Pokemon, we inputted a move name, so you wanted to use tackle, right? You inputted a move name, and then the code for running tackle would have to be right here in the if statement. Right? It had to be all this huge, look at this, all this code for using these moves. Right? But now we can actually organize our moves away from the if statement. Again, we're talking about an API. The point of the API is to hide the complexity to make it more human readable. Right? Because look, there's a bunch of complexity all right here in the open. We want to kind of put that complexity away, and we don't have to look at it all the time. Right? We write it once. We write the complex parts once, and then we don't have to look at them again, ideally. So let's take this code we had before and demonstrate how we can simplify it nowadays. So we're going to go down here to the bottom. Let's get rid of all this stuff. All these Pokemon we're making. We'll just leave 2. We'll leave Zanzu and Dix. They're going to have a lover's quarrel. Right. We have 2 Pokemon here. So Zanzu can get, so Dix can get behind that, huh? I'm sorry, I see someone else there, but the username is so bright I can't even read it. It's something TV, huh? Pokemon board, whatever your name is. Okay. So let's see here. So now let's go down here. We're going to pick a little comment here. you know, this is where, thank you, Dix, Sep TV. Welcome aboard, dude. There's the Pokemon battle starts, right? And there's going to be a while loop, just like before. As you guys remember, a while loop will run repeatedly as long as its condition is true. So our condition is going to be while Pokemon 1.hp, right, now he has this HP attribute, is greater than 0, and Pokemon 2.hp is greater than 0. So as long as both our Pokemon are still standing, they're not fainted yet, keep on running this loop. Just keep on looping forever. And the first thing we're going to do is we're going to ask the user for a move name. Right? We're going to say, user input equals input. Remember this method? I haven't used it in a long time. It's function. This is a simple function built into Python that asks the user for some kind of textual data. We're going to say, give it a prompt as well. We're going to say, what move should, Pokemon 1.nickname plus the plus Pokemon 1 monster type plus use. Right, so the whole point of that line was to make a little prompt for the user. What move should Zanzu the Cyndaquil use? Right, let's break this line here. Okay. There you go. Simple little string there. Fuck grass Pokemon in general, to be honest, especially Oddish. Oddish is the best. Bulbasaur is the best. I love grass types. I like grass types and bug types. Okay, so we have this little user input question here. What move should so-and-so use? Right. Then we're going to run whatever code that you want to do. So we're going to say, after here, we're just going to say, Pokemon 1 dot use user input on Pokemon 2. Literally nobody likes Oddish, and Bulbasaur is okay, but nobody picks it. I pick it, you son of a bitch. I wanted to use it in Pokemon Yellow. They're like, nah, son, you get Pikachu. Okay, so there you go. And now we can just say, for now we're going to have the user, the other Pokemon use Tackle. So now we're going to say, Pokemon 2, he always uses Tackle. On, Pokemon 2. Pokemon 1. Okay, so let's look at how classes have made our code simpler, right? So over here in our day 2 code, we had to, whatever string the user input in, like tackle or headbutt or whatever, we had to test it in an if statement, right? Every single option had to be tested individually, right? If it was tackle, do this. If it was flamethrower, then do that. If it was, tail whip, then do this. And again, we had all this code for running the move directly inside the if statement, right? So that was a tackle right there, basically, right? So what's interesting now is that because we have a dictionary that's attached to our Pokemon, we don't even need to use an if statement. We'll just say, look how our code has changed over here. So let's see right here, right? We're just saying input a string, give us a string, and then use that move. Use the move at that string, right? Very, very simple. So let's just do that right now. Let's run it. Okay. What move should Zanzu the Cyndaquil use? Use tackle. Boom. Oh, it's kind of hard to read. Let's actually fix that. Before I go any further, let's fix that. Can I exit this if I were to hit Control Pause? How do you break out of this loop? Oh, that works. I just caused an error, but let's put a little line break in here. Let's just print off a blank line between the two Pokemon's turns, so we don't have to look at all this. There you go. All of it lumped together. And then let's also put a space here. Let's try again. Okay, so let's hit F5. There you go. So what move should Zanzu Cyndaquil use? I want him to use tackle. Boom. Okay, so Dick's, let's scroll up. Let's make it a little bit bigger here. Like my ex-girlfriend used to do back in the day. Okay. That'll do. So what move should Zanzu use? He uses tackle. Right? Zanzu the Cyndaquil tackled at Dix like the Cyndaquil. Dix took a 6 damage. Dix has 4 down health remaining. Tackle has 9 PP remaining. Now, Dix the Cyndaquil tackled Zanzu the Cyndaquil. Okay. Zan took 6 damage, right? Has 49 health remaining, because they're both the same kind of monster, so they have the same amount of max health and stuff. Now, what should Zan do? Let's have him tackle again. Okay, so now Zanzu, now Dix only has 43 health remaining. Now again, back in the old code, it was kind of complex to constantly subtract the opponent's health, right? Let's go back, let's go back here. Right, so in this code here, we had to constantly reduce this Pokemon to HP object, right? This attribute, this variable, and we had to get a return value from this deal damage function, right? But now that the HP is attached to the Pokemon as an attribute, right? Now that it's attached directly here to the object, it's very easy to change it for better or worse. We talked last time about how that can cause problems, right? The reason that we have functional programmers to this day is that some people swear that having all these changing attributes is very dangerous. It makes bugs a lot easier to happen. Why not just control this? I'm sorry, Dark. It's not really I'm not in the habit of doing that. I like to go up here and do it manually. So that's one of my things. Okay, so now this code is so much. Look how fucking simple it is. We have 1, 2, 3, 4, 5 lines of code basically that it's much easier to read, right, compared to our old code where all the complexity was out in the open, right? One thing that classes really help with is they help you put the complexity somewhere else. So out here we have like all these lines here just for running a few, look at all this shit. Look at all this shit. That's a huge number of lines of code. And we've replaced that basically with 5 lines. Thanks to the magic of classes. Because we have all this complexity, we've moved it elsewhere. We moved it outside of our main loop. We moved it to the object. So we have that complexity up here now, essentially, right? But where the code actually runs down here, it looks very clean. Real coders use Control plus S, like me. Dix, you can do whatever you want, man. You can do whatever you put your mind to. Right now, you're fully dedicated to being a brain surgeon on people, trying to open up people's heads and stuff. If you wanted to, man, you'd be a superstar programmer because you have the Control S. You've got it in you. Okay, so we've got a couple problems here right off the bat. One problem with this situation is that we can bug our code more easily than before, right? In our old code, look at the old code. In our old code, we had this if-else statement, right? It was if they inputted tackle, L if they inputted flamethrower, L if it was tail whip, L if it was growl, and then finally we would say else, Cyndaquil doesn't know that move, right? But we have no such safety net anymore, right? We don't have an error message yet for if they put in the wrong move. So why don't we go up here and let's run this code again and see what happens if we put in a move he doesn't know, like tail whip. He doesn't know tail whip, right? He only knows tackle and comb hair. Okay, well shit. It crashes. It literally just crashes. We put in the wrong move name. It just says, key error, tail whip. So it's a key error because we inputted in tail whip right here. Where was it? It's a Pokemon's right here. This key for this dictionary, right? It's a move name it's not in that dictionary. We only have tackle and comb hair. We don't have anything attached to this string tail whip. So that sucks. What can we do about it? Well, maybe it's time to talk about accepting errors. So Faust says 100. Let's go. So you gotta know what works for them and stick with it. Dix says, real coders know my way is the right way, like me. I agree with Dix. Guys. Whatever Dix says, yes, don't ever disagree with Dix in the chat, please. Because you'll find over time he's always correct. I have learned that over knowing him for a few months now. Like more than a year now, actually. You don't ever want to argue with Dix. Just accept his law and abide by it. Okay, so let's talk about exceptions. Right? Let's actually let's go make a whole new file, in fact. Right? Just for an example for you total noobs out there. And let's save this as, exceptions example.py. Okay, guys, so let's, in Python, certain things that you attempt to do will crash, your program. Because you suck at programming. just like me. Right? Things you do are going to crash a program. But when a program crashes, it raises an exception, which you can think of like an error message. Right, let's go look at our exception we just got. Let's go look at that. Right here. So let's see here. So we got a key error exception, right? It said key error, tail whip. There's no such key called tail whip in that dictionary. Right? So we got this key error exception. Exception just means like an error. It's just a, you know, you can just say right here, you know, exception is just a synonym for error, right? Same thing. I don't know why they call them exceptions, but they do. What's really cool about Python and some other, you know, modern languages is that you can catch an exception, right? When you catch an exception, you can prevent your program from crashing by cleaning up after the error. All right, let's do that real quick. Let's use key error, for instance, right? Let's make a dictionary, you know. Our dict is going to be a very simple dictionary. It's going to say, you know, Dick Zucker. Why do I feel like that wasn't spelled right? Isn't that spelled right? That's weird. I must be having a stroke. Huh. Okay, that's Dick Zucker, and he's cool. Right? Then you've got Zanzu. He's cool. Right? And you got Vencabot. He's kind of lame. Right? And you got, you know, Step TV. He's all right. And you got, you know, our friend Darker Cosmetica. And they're kind of meh, right? So let's, you know, we have this dictionary. All this dictionary is doing is it's mapping a bunch of strings to some other strings. Zanzu is more hot than cool. Okay, we'll make Zanzu hot then. Right, so all we're really doing here is making a dictionary where we map one string to another string, right? That's all we're really doing there. We're going to invoke key errors. So let's print off, you know, we're going to print off, you know, our dict, you know, Dick Zucker, right? What's going to happen here, do you think, guys? Because they're total noobs. I'll tell you. Don't even bother answering that question. I'm going to tell you guys. This is going to print off cool, right? Because we're accessing our dictionary at the key Dick Zucker. This is going to print off cool because Dick Zucker, you know, that key is associated with cool. Let's try it. Yeah, so he prints off cool is all it does. However, what if we try to print off our dict, you know, Bloody Angels 67? My friend Blake. Right, let's try to print that. The problem with that, you guys already know what the problem is, right? That is not a key in our dictionary. There is no key yet by that name. Right, so we're going to get a key error. Right, see, our program crashed, right? It said cool right there because that was fine. You know, the first print call is fine. It calls, you know, Dick Zucker from our dict. That's a key that exists. But the second one crashes the program because there's no key in that dictionary called Bloody Angel 67. We get a key error. Okay, well now, you know, how can we run that same line of code without crashing our program? So let's make a third line. Right, let's go down here to our third line, print off our dict, you know, Darker Cosmetica. Right, so that line should run just fine. The third line should run, right? We only have a problem with the second line. But the problem is that the second line crashes the program, so we never reach the third line. That's our problem. Right, so let's run this. Yeah, see, we got the cool part. That works great. That's when we use Dick Zucker as the key. Then we get a crash here on a key error exception. Right? And then we never get to the third line because our program's already crashed. Well, we can use a brand new statement called try. Right? When you use a try statement, you can specify a type of error, let's just say exception, that you're expecting. And then, if that exception happens, you can clean up after it. So around, this second line, we're expecting an error to happen, right? Let's just say, just try this. Don't necessarily crash if you can't do it, but just try it. Just try it. And then we can say, except print our program almost just crashed. Right. So what we're saying here is try to do this thing. Right, try this thing. If it don't work, no big deal. Just print off a message saying it almost just crashed, and then carry on with your life. Let's run this. Look at that, see? So it prints off, the key for Dicksucker. That ended up being cool. Our program almost just crashed. It accepted that error we got. And then we have, the one for Cosmotica, which is meh. So the whole thing ran. The whole thing ran. It's just that when this one tried to run, it raised an error. But thankfully, we caught it right here. We caught the exception right here. Okay. Cool beans, right? But there's more. There's more to just trying and accepting. You can actually have different... Let's make an example. What's another good error message? Let's try... let's just try using a function that doesn't exist, right? This function doesn't exist. Let's just say, doesn't exist. Give it an argument of our dict. Right? We don't have this function yet, but we're giving it an argument anyway, so who cares? Right? We run this code here. It'll give us the same message. Right? Our program almost just crashed, and it finishes off, right? But what if we wanted to run different cleanup code depending on what kind of error we got? Right? So let's say we fix this to like Vencabot. Right? And we run the code. We get the same message. Our program almost just crashed. Because the error is not a key error anymore. The error is an error that we're using a function that doesn't exist yet. But we're just accepting them all the same and printing off the same message. Why don't we instead say except key error? And we're going to print off our program almost just crashed because that key ain't roll. That key ain't roll. That key ain't roll. You didn't make it yet. Didn't even roll. How about we also accept? I don't know the other key, what the other error is actually. Let's see what the other error is. All right, let's run this now. It's a name error. See, that function does not exist. So basically, if that had been a key error, we would have accepted it. But because it was a name error, it still crashed. Right? We don't handle that. Let's actually just do this. Let's just say, accept name error. Print, our program almost just crashed because that function ain't even roll. Right? There's no function by that name. So now we can change the path that our exceptions follow, our try block follows, based on the error that we get. Keys can't even roll in 2K18. Ain't even roll. Says, I am pretty warm. How'd you know? I'm pretty warm too, guys. Got the furnace going. Got this nice little sweater on. So now our code changes based on what kind of error we get. See? So that function didn't even roll. But if we were to feed this with bloody angels again, right? It's gonna give us a different message. Right? Because that key ain't roll. So basically, based on what kind of error it gets, then it will do a different thing. So that's basically try and accept in Python. You can wrap your error-prone code in this try block, and then based on the error you get, or all errors, if you just accept with no message there, right? If you just accept like that, that'll catch all errors, which is usually not that great of an idea, because usually you want your program to crash if it's something wrong with it, right? So you usually want to accept a certain kind of error, and then if not that error, then crash. But yeah, so we have this little statement here that's error-prone, and then we're going to accept it, and then do a little cleanup code there, and then just keep on running. How do you get the exception type itself when catching it? Okay, we can do that. You can accept as, right? So here's another bit of code. Accept as, my error or whatever you want. I think Darker must probably know how to do this already, but just wanted to remind me to talk about this a little bit. you can actually get the error object itself by using this little statement here, except as. Right? So when you accept as, you get a new variable back. This new variable is the error. Right? The actual exception is now an object for you to look at if you want. Let's do that right now. Let's just get our error, and then we can print off our error. So let's just print off, whatever this thing is. Right. Except as. Except as. Get your mind out of the gutter. Oh, invalid syntax. Oh, I have to accept a certain kind of error. Let's just accept exception. Right, that's the parent class for all exceptions. Right, so you have to accept a certain exception. We can say like key error, for instance. Right? Let's do that for simplicity's sake for now. We can talk more about inheritance in a second. So now we're going to accept this key error as my error. Then we're going to print off whatever we just got from that. Let's do that. Okay, so when you accept an error, you get that error back. And what key error returns apparently is the key that you wanted to try and get and you couldn't get. Right, let's look at that code. Let's look at this. It's running again. So basically, when we accepted this key error and we fetched it, right, we got it as my error. If you print off my error, it gives us the key that we wanted that didn't exist. I think that you can also, there's probably a way that you can actually get the error type too. Let's go and look at our, by the way guys, we're enjoying the music of my friend Albdat. That's a Bandcamp, albdat.bandcamp.com. Very ambient, kind of droning. I find it's pretty good for programming, helps me focus a little bit. Very nice guy. He's on Twitter as well, at TC640B. Go say hi to him. But his music's all for free, guys. That's aubdat.bandcamp.com. Very, very cool stuff. But yeah, let's figure out how to get this error type. So let's look at exceptions. Okay, so let's look at the built-in exceptions. Okay, what do we got here? Args, exception, blah blah blah, assertion error. I want to learn about like what kind of attributes they have. Whenever I wake up. Okay, use exception. Can I read about this? I want to read about the class. I'm going to Google it. Python exception attributes. I want to figure out how to get the actual... there's exceptions. Now let's just look at the Stack Overflow page. Here we go. So it's got, here's the attributes right here. I want something like, do I want class? Let's try and look at the class. Maybe that'll help us. Let's go here to our example. I want to print off my error dot class. Will that help us? Or nah? Let's find out. Oh, there we go. So it's a key error. Okay, so that helps us find out what kind of error it is. Basically, you get this error object back, and you can access that error's attributes, or just print it off directly, or whatever you want to do with it. It's kind of nice. You can get all kinds of stuff based on whatever error you got. And most of the time you need that. Most of the time you use an exception, you accept it as something, so you can get some kind of data from that error. Right? You want to use the data in that error to do something else with it. Right? But in our example here, we're just going to accept the error and do our thing. Do our damn thing, do our thing, your thing. I'm fresh squeezed juice. You're that tang. Okay, so let's go back to our code here. So how can we use try except to fix our example here, where we supply a move name? We're going to ask you, what move should somebody use? And you type in a move that he has, it runs. If you type in a move they don't have, it crashes. Well, why don't we go to this line and we're going to say, try to use that move. But we're going to accept a key error as, my error, right? Right. So basically, we're going to get this key error that's going to happen if it's the wrong move name. And we're going to say, we're going to print off a message here. We're going to print off, Pokemon1.nickname plus doesn't know plus, and we know for sure, we know that myError, if we make it into a string, it gives us back the erroneous key, right? Let's see how this works. It might not work. So the way I'm envisioning it here, guys, is I'm envisioning it as if you get a key error here, right? If you put in the wrong key, like a move you don't know, we're gonna say Pokemon 1, you know, their nickname, doesn't know, and then whatever you just entered. Well, let's make it simpler. Let's put in the user input, right? We already know the string. There, that should work. Okay, so we're gonna say if they put in the wrong input, print off this message, then go back to the top of this loop. Boom. You guys might remember from back in the day when we were starting off this project. Let's print a blank line too. Oh, we don't need one. This has one right here. But we talked before about loops and how they work, right? Like while loops. The continue statement says, don't even continue the loop. Don't even continue down here. Just go back to the top of the loop. That's what continue means. That's what this line right here means. So we're saying Zanzu doesn't know that move, and then ask again. Go back to the top and ask again. What move should he use? Let's try this. So Darker says a good old accept pass and move on with your day. No, don't ever do that. Yeah, the joke that our friend Darker is making is that you could just, if you have a problem, like an error that's popping up, you could literally just accept it and then do nothing. Just go on with your code. But that makes no sense, right? Usually when you catch an error, you want to catch it intentionally, and you want to do something based on that error. Don't ever use accept as a way to just ignore that a problem is with, ignore a problem in your code. You don't want to use it to ignore a problem in your code. You want to use it to look at an error that you know is going to happen, or you think has a very high likelihood of happening, and then deal with it in an elegant way. In this case, we're using it as a way to say, the user typed in the wrong move name, ask them again for a move name. Right? That's what we're using it for. So we're basically using this error to our advantage. In fact, most of the time you use an error, an exception, you use it that way. You use it not as a way to crash your program, but instead as a part of your code. Use it as a way that, because errors shouldn't always break your code. Sometimes an error just means somebody entered something wrong, or maybe you're using an object type that doesn't always behave as expected, but you can use the error to your advantage and do something that you want to do with it. In this case, we're actually using it to save some code, right? In our old code, we had a bunch of if, elif, else. Let's go look at that. So in our old code, we had all these elifs, and then an else statement at the end, right? We're using this error to our advantage to save us a lot of lines of code. It was El Soldado, not really hacking, no. We're really just doing some really, really basic beginner programming. Okay, so now we have, we get the input from the user, and we try to use that input as a move name. If that move does not exist, we get this key error, and we use that to our advantage here. In fact, we don't even need to save it as anymore. We're not using myError anymore. We accept the key error, and then we go back to the top. Let's use this code and see how it works. So I want him to use tackle. Easy. Tackles them, no problem. No, it's not basic. It's not a language base. There's a language called basic. This is actually Python, but it is a very beginner level Python. We're actually getting kind of more into the intermediate levels now, but it's really kind of like lower intermediate, kind of like things you would learn as a new programmer. It's not that complex, dude. It's not that complex, really. It's only a few lines of code. But yeah, if you go back to our first, if you guys are watching right now and you're kind of overwhelmed, go to my YouTube channel, guys. That's at youtube.com/Venkabotarchive. That's youtube.com/Venkabotarchive, or just search on YouTube for Vencabot. You'll find me. We have all of my streams, right? We started off very, very simple. And this is our 5th stream. We do it weekly here on Fridays. And by this point, we've become a little bit more complex. But if you want to start back at day 1 and learn the very, very basics of like what a variable is, how to use if statements, that kind of thing. That's all on YouTube right now for your convenience. Go check it out. It's actually in a playlist called Intro to Python for your convenience. Okay, so now we have this code. We're running it here. Right. Let's have him use headbutt now. He doesn't know headbutt, guys. It's going to cause an error. But our error should get caught now, right, in that try except block, that try except code, which means we should get an error message from the game itself, and then go back and ask again. There you go. So we took some code that would have crashed the program, and instead we're using it to our advantage now. We're saying, he doesn't know headbutt, ask him again. Right? Let's have, tail whip. He doesn't know tail whip, ask him again what to use. Let's have him use a tackle. There you go, he knows tackle, right? So that works fine. So by using that error that would have crashed our program, we have made our program work much better. Now we have this nice little message pops up and asks the user again what to use. It's kind of cool. All right, so we have the second Pokemon. All it uses is Tackle, right? That kind of sucks. Let me use Comb Hair here to make sure Comb Hair works. We only have 2 moves right now, all right? Okay, so Zanzu combs his hair. Okay, that's cool. El Soldado, I'm programming a Pokemon clone, like the Game Boy version of Pokemon, El Soldado. So we have this little Pokemon battle here, right? Where we have 2 Pokemon, and they both know some moves, and they're attacking each other, and they're losing health. See? So if I tackle again, right, I'll take my turn. It says, Zanzu, we should use Tackle. It says, Zanzu tackled Dicksucker. Dicksucker took 6 damage. Dicksucker has 37 health remaining, and Tackle has 7 PP remaining. Then we say, no, then he got his turn. So Dicksucker attacks Zanzu. Now, Zanzu took 6 damage. Zanzu has 31 health remaining, and Tackle has 6 PP remaining. Right, so it's kind of like Pokemon, basically. We're taking turns fighting. Then eventually, one of us is going to faint. Right? So now, Dix is at 19 health, no, Dix is at 25 health, and Zanzu's at 19. So one of us is going to faint eventually. Here we go. So now Zanzu only has 1 health remaining. All right, so next turn he's going to die. Let's see what happens here. There you go. Okay, so it says, Zanzu has -5 health remaining, and now the fight's over. Right, that's the end of our code there. So why don't we, rest in peace, Zanzu. It's okay. He'll live to fight again. He'll live to fight again. So now let's, when our code ended here, as you can see, it kind of ended right here, right? There was no message. That's just the end of the code, right? That kind of sucks. So let's go back down here below the while loop and say, if we got out of the while loop, if Pokemon 1.HP is, greater than 0, right? If Pokemon 1 is still alive, basically, then say, winner equals Pokemon 1, right? Else, winner equals Pokemon 2. So let's make a loser too. So we're gonna say, winner is Pokemon 1, loser is Pokemon 2, and we're gonna say here, if it's the other way around, we're gonna say that the loser is Pokemon 1. Let's very briefly review if-else statements, guys. We haven't used them in a while. I haven't used them in weeks. If you guys are beginners, you might not know what that means. We're saying, if this condition is true, then do this. Else means otherwise, right? So if this is true, do this. Otherwise, do this. Now we know that one of these guys is dead because this while loop runs until one of them dies, right? This goes forever and ever and ever and ever until one of them faints, right? So if we even got down here, that means that somebody fainted, right? If nobody had fainted, we'd still be up here. So we're saying, hey, listen, if Pokemon 1 is still alive, then he's the winner and the other guy's the loser. Otherwise, we know that, Pokemon 2 is still alive, right? That means that, we have this, actually, we don't know that. It's actually a bug. I'm putting a little note here. This is a bug. But yeah, we're going to assume for now that that means that, the other Pokemon's alive, Pokemon 2 is alive. And we're going to say, the winner is Pokemon 2, the loser is Pokemon 1. Then we're going to go down here and we're going to say, print loser, let's just say, loser dot nickname plus the plus loser dot monster type. So we're going to say Zanzu the Cyndaquil plus has fainted. Print winner dot nickname plus the plus a winner dot monster type. So Zanzu the Cyndaquil plus is the winner. Right, a little bit long there. Let's break this line. All right. There you go. So now let's run this code, and now we have a little, kind of like a neater message. Look at this message here. It's a little bit neater now. Let's try this. F5. So let's have Zanzu just comb his hair. He's going to get his ass kicked. He's sitting here combing his hair like an idiot while Dicksucker is just destroying him. Come on, Zanzu. What are you doing, Zanzu? What are you doing, man? Oh my god, he's got 25 health left. 19 health left. 13 health left. 7 health left. Oh my god, dude. Tackle him, dude, tackle him. Hail Mary. Hail Mary. Ah, it didn't work. Okay, so now we have Zanzu the Cyndaquil has negative 5 HP remaining. Zanzu has fainted. Dicksucker is the winner. Right? Cool. That works. But before I even go on, let's address this bug that I noticed that we have here. Maybe this bug here. This bug, here's the problem with our program right now. We assume that one of these Pokemon is alive. Right? And it stands to reason. Right? If one of them beat the other one, then one must be alive. Right? Wrong! Wrong, you big dopes. Jesus. Let me tell you why. That's because no matter if Pokemon 2 is alive or not, he always gets his turn. Right? So Zanzu gets his turn right here. Right? And then no matter what happens, Dicksucker gets his turn right here. So there could be a situation where Zanzu deals the killing blow to Dicksucker, and then Dicksucker, after he's already fainted, attacks Zanzu and knocks him out. So they could both be knocked out, right? Because he gets a turn even if he's knocked out right here. Did you say Dicksucker, sir? Was that Morwick? Welcome aboard, dude. Yeah, his name is for my friend. I have a friend named Dicksucker. So yeah, our Pokemon is named after him right now. How you doing, dude? I'm not sure we've met. I'm David. So let's make a little thing here. We're gonna say, hey, listen. If Pokemon 2.HP is greater than 0, then he gets a turn. So if he fainted right here, right? If he got knocked out by Zanzu, then he don't get a turn. Right? That makes sense. It's Python, yeah, it's Python. Yeah, so he only gets a turn now if he actually is still awake, which stands to reason, right? That makes sense. So now this is not a bug anymore. Now we know for sure by the end of our code that one of these guys is alive, because now they can't both be dead. Previously they could both be dead due to the fact that Pokemon 2 can get a turn after he's already knocked out. Okay, cool. So now our code is very much like our old code was, in terms of the game fully working, except that in our old code, a Pokemon 2 could choose a move at random, and right now he only uses Tackle. So let's fix that. Before we talked about this this library called random. Let's import that right now. I'm having a great night, Morbick. How about you, man? Import random. All right, guys. Brakes. Put the brakes on. We've been talking about object-oriented programming for so long on the channel here, for about 3 nights now. We've been talking about the basics of classes and stuff, that there are a few things we haven't talked about in a long time. We haven't talked about if-else for a long time. We kind of covered that again very briefly down here. But we also haven't talked about importing in a long time. So let's cover that very briefly, guys. In Python, you have certain functions that are built into Python itself, such as input, right here, where we use the input method or input function and get some text from the user. You also have print, right? That's a built-in function. You always have access to print, no matter what you've defined as a user. However, in Python and other languages, you can actually bring in other tools as you need them, in this case using the statement import. Let's talk about that. So Mark says, where's a good place to start, sir? If you check my YouTube channel at youtube.com/Venkabotarchive, or just look for Vencabot on YouTube, you'll find my playlist, Intro to Python. We started off super, super basic. Literally like day 1 programming. You have never programmed anything before in your life. And we talk about the very basics of like defining variables and what it means to be a statement, that kind of thing. That's on YouTube. And this is our 5th day on this project. And as the project has evolved, we've added in more complexity. We've kind of tackled more complex subjects. So the first few days was just about using variables and using statements and using logical blocks like if, else, and while. And then now we're looking more at object-oriented programming, which is to say we're looking at classes and methods and attributes. Things are a little bit more complex. But as you become stronger as a programmer, they actually make your life easier. So although they appear more complex at first to a beginner, they will make your life easier over time. But that's why we're kind of trying to introduce ideas in order of complexity, starting off very simple and getting more complex. Today is, again, day 5 for us. our 5th week. We do this once a week, guys, on Fridays. It's our 5th week, so now we're looking at classes and stuff. It's a little bit more involved. In any case, let's talk about importing. So we want to import a library, it's called. A library called random. Let's go look at that library. At docs.python.org, go to the library reference, and we have all these cool libraries. We can access libraries called, date time, calendar, collections, bisect, array, copy. These are all libraries that themselves come with tools, right? They have more tools if we want to use these tools. Now, most of the time, we don't need math, right? We don't need all the cool things in math. We don't need all things that are in iter tools. We don't need all the cool things that are in pathlib. And because they're only used some of the time, then we import them as we need them, right? In this case, we need random. I want to use random numbers and stuff. So I'm going to import random. What does that mean? Well, that means that now I have access to all these cool things in random. Random comes with a thing called seed. It comes with a thing called getState. It comes with a thing called setState. It comes with randRange and randInt and choice. These are all cool functions it comes with that I can use now. Thank you for the follow. That's YHarian. Kind of a cool name. I'm probably pronouncing it wrong. Wehar Ion. Welcome aboard, man. Have any questions, let me know. So more of some music nerd, huh? What are you doing here, man? Want to learn some programming? I'm a music nerd as well. I love music. I'm actually a music student. I should say at an amateur level. Do not know what you're talking about, but I'll check out your VOTs. Yeah. Cool beans, Morwick. I've actually used programming before to write music. You actually use APIs to create synthesizers and create random compositions, that kind of thing, using programming. If you learn it, it's pretty fun. In this case, we're going to use a function from the random library called random.choice, right? So when you use random.choice, it says returns a random element from the non-empty sequence seek, right? If seek is empty, it raises index error. So basically, we give it a list. We give this function a list as an argument, and it gives us back a random thing from that list. Use reason and logic. I never noticed, Morwick, that they have very similar names. Reason and logic. It must be the same brand, huh? The same developer. That never struck me until this very instant that reason and logic, both are music tools, by the way, guys aren't musicians. They're what they're called DAWs, digital audio workstations. That's where you make music at. One program is called Logic, one's called Reason. They're not the same brand? Just a total coincidence? That seems weird. Reason and Logic. I've used them both myself. That's crazy. Okay, so let's go here to our example for today. We have this random library. Now we can use it, right? Let's use it down here. Let's say for the opponent's Pokemon's turn right here. Let's break a line here so we know we have another turn here. I'm gonna put some comments in here too. This is gonna kind of fugly. Let's say, this is our Pokemon's turn. And this is the opponent's Pokemon turn, right? This is the opponent Pokemon's turn. Right. So this code here is for our turn. We put in a string. We get asked what move to use. Then we use it. If we can. If we can't use that move, we get an error and we go back to the top and ask again what move to use. But this is the other Pokemon's turn. Right now, all it does is it tackles. It always tackles, right here. So this Pokemon, all it does is tackle. If it's awake, this means right here. This line means if it's awake, right? If it has HP greater than 0, if it's not knocked out yet, then all it does is it makes a blank line, and then it tries to use tackle. In fact, we don't even need print. Should always happen. Let's put this outside of the while loop. Outside of the if statement. Right. So print a blank line, then the opponent gets a turn. Right. He can tackle. If he wants to. He can leave his friends behind. Okay, so right now we're always using tackle, but let's instead use a random move. So we're going to say, random move name equals random dot choice, right? Let's go look at choice again. So random dot choice, we supply it with a list, and then it returns a random element from that list, right? It gives us a random thing from that list. So we're going to say random.choice, and the list is going to be, Pokemon 2 is move dictionary, but we're going to run the keys method on it. So what does keys do? What's moveDict.key? Let's go look at that real quick. Here's a follow more. We stream here for 5 nights a week, 40 hours a week, guys. But it's mostly gameplay. We do lots of gameplay on here. Right now we're doing Mega Man Legends 2. We're doing Street Fighter 3 Third Strike. We were playing Hitman this week. But on Fridays, we do programming here for the first 3 hours. That's how we start our Fridays. If you guys see me playing Mega Man or something, do not panic. Do not panic! I will do some more programming on Fridays, I promise. How do you know what command to use? Nice, I stream also over in music. Oh, nice, dude. Yeah, I'm thinking about streaming on music myself at some point. Sounds like fun. Well, I know what command to use because I'm experienced. I've been programming for 20 years. But here's what we can do, right? We can go, let's say we're total beginners, right? We can say, here's what I want to do, right? I want to supply let me show you how the code works here. Let me show you how the code works. Let's go here. Let's get rid of this. I don't want to make it too complex right now. I want to say, I want to supply a random move name, right? I want to supply a random move name to use, right? Right now it always uses tackle. Here's the move name, right? But I want to supply, a random move name right there, not just tackle all the time, right? So how do I get that random move name? Well, I want a random key from the Pokemon's move dictionary, right? Because we define that move dictionary up here, right? If you guys are just joining us, you might not realize we have this thing in our Pokemon class called a move dict, right? And the move dict is just a dictionary that maps the string of that move's name, such as tackle or tail whip or whatever, and we map that to the actual move object itself. So in this case, we have this tackle move, right? This class called tackle. It does all this cool stuff when you use it, right? It damages the opponent, basically. So we want to say, I want to tie the name of that move to the move in the code, right? So that's what this little block here does. It takes a list of move classes, and it makes a move from those classes, and it associates that name with that move in this thing called the move dict. That's what it's for. So we have this thing. So what we're going to do is we're going to say, well, I want a random key from the move dictionary, because the keys are the names of the moves, right? I'm going to put that right here, in fact. Let's see here. Because the keys are the names of the moves. So we know what we want, right? We know we want a random key from the dictionary. So how are we going to do that? Well, let's see if there's a way we can do that. Let's go look at the dictionary and the Python documentation, right? So if we go up here to the top of the documentation, we have this list of built-in types. We can learn all about, integers. We can learn all about strings, right? We can learn all about all kinds of cool shit. Let's learn about dictionaries right here, right? This mapping types, dict. Let's learn about dictionaries here. The mapping object maps hashable values to arbitrary objects. Okay, mappings are mutable objects. Okay, blah, blah, blah. Let's look at what kind of things we can do with the dictionary. Okay. So we have this len method, function we can use on it, right? If we put this len and we use the dictionary, it says returns a number of items. Okay, well, if we have 2 moves in our dictionary, then len dictionary means it gives us the number 2. That's kind of cool. We can know how many moves we have. That's kind of nice. We'll keep that in mind for later. We can do this D key thing. We're going to use a dictionary and the key. We've been doing that before, like, move dict tackle. That'll give us back our tackle. That's kind of cool. We can assign. We can delete things. That's kind of nice to know. Right? We can delete, an item from the dictionary using the del statement. That's cool. What's above that? Let's go look at this. What's above this? What's an example? This is about how dictionaries are defined, right? So this is we did this on our stream, actually. In our last stream, we talked about dictionaries and how they're defined. These are different ways you can do it. Right? You can define it using the dict, the dict function. Define it that way. You can define it using this curly bracket syntax by supplying a key and then a colon and then the value. You can do it by zipping 2 lists together. You can do it by supplying, these tuples manually, etc., etc., etc. It all comes out the same exactly more. It all comes out the same. The point they're making right here, in fact. The point they're making right here is that even though these are all defined differently, they all have the same exact value. They're all true. So you can go about things in multiple ways. The way that we prefer is such as right here. We usually do it like this. we use the curly bracket syntax. We supply a curly bracket, then you do a key, which in this case is a string, and then a colon and a space, and then your value, which is another string in our case. Right, it's a simple, very simple dictionary right here. We supply a key and then a value. We found out that len, len dictionary, the D is for the dictionary, that gives us the number of items in the list. That's kind of cool. We know that we can add items this way by supplying a key and then using assignment. That's kind of nice. Right here. Right. You can supply a key and then it equals a value. Lendy. Oh my God, Zanzu. Don't, Zanzu, don't. All right. Let's all be adults about this. We have a conditional statement here. Key in D. So we're saying if this key is in D, then return true. That's kind of cool. So you can do a comparison. You can do a conditional test. Do this code if that key is in the dictionary. Otherwise, do this code. That's kind of cool. You can clear the dictionary. You can copy it. Very nice. You can get stuff. But here we go. This is what I was looking at here. Items. Returns a new view of the dictionary's items. So we get this items method. And what it does is it will give you a list of key value pairs in return. So let's just do that, for example. Let's do that. So let's go here to our, our example. Let's get rid of all this code here. Our example for exceptions. This is our example dictionary, right? Let's just say, print our dict.items. Right. If we print off this the items, we're going to get a list of the pairs. There you go, see? So we get these pairs back. It's a pair of, the key and then the value. The key and the value. But here's the code I want to look at today. Keys returns a new view of the dictionary's keys. Okay, so let's go back to our Pokemon example here. We know that we want a random key, right? We want a random key from this list. And if we use keys right here, then we can get a list of those keys. See, we get only the keys. Right? You get only the key parts of it. That's cool. So if we combine that what we know about random, remember we had this that random library? It can take a list of anything and give you back a random thing from that list. So because we can use keys to get the keys from the list, we have a list of those now, or from the dictionary. For instance, let's actually run that right here, for instance. Let's import random. Right. Import random. And we know we have this thing called random.choice, right, which it picks a random item from the list. Let's say, random key equals random.choice our dict.keys. Let's make it even simpler to read. Let's just say, list of keys equals our dict.keys, and then random key is a random choice from the list of keys. Right. Now we're going to print off our random key. There you go. So we define a dictionary, right? And the dictionary is a bunch of key value pairs. Here's the key, here's the value, and a comma. Here's the next key, here's its value, then a comma. Right, here's another key, and so on and so forth, right? We've got a few different keys here. Then we make a list of those keys by just using this keys function, right? The keys method of the dictionary. Okay, so a method is just a function that's attached to an object, right? And we talked about how the period in programming is like an apostrophe S, right? In English, it means ownership. So we're saying, use our dict's keys method, right? So we have this list of keys now. Now we can use random.choice, which again is apostrophe S, right? So that means the random library's choice function, right? So we imported random right here. We have the random stuff now. We're using random's choice function on our list of keys. And we talked before about how when you use random.choice, you give it a list. It gives you back a random thing from that list, right? So let's see how this works. I'm sorry. That's for indexing. Hang on, let me fix this. So basically, the problem with this is that this doesn't actually return a list. It's kind of confusing. I'm sorry, Morwick. Have a good night, dude. Again, we're a little bit simpler in the earlier streams. Go check those out on YouTube. You have a good rest, my mans. And enjoy your music streams. We talked before about how dictionaries return this confusing object called a dict view. I wish that Python didn't do this, to be honest. It's a complaint I have with Python 3. But when you run things like keys, if you look at the documentation for keys, it doesn't say it returns a new list like it should. It returns a new view of those keys. Right? And a view is a view object, basically. And they're very much like lists, except that there are certain things they cannot do. But here's what you can do, though. You can convert a view to a list, and in my experience, you always should. But I oftentimes forget. Simply by running the list function on it. Let's go see what list does, actually. So if you go up here to built-in functions, you have something called list. And it says it's actually a mutable sequence type, and you can convert things to a list that way. So let's go here to our exceptions example. We're going to make this into a list, right? So it's a list of keys. We're going to use list. Let's actually just make it simpler, right? We're going to call this view of keys. It returns a view, right? It doesn't return a list. Then we're going to say the list of keys is the list version of our view of keys. Right, that's what's happening here. So we get a view using keys. We convert it to a list. Now we can use that list in random.choice. Okay, let's try this now. That's more like it. So it returns a random key. Every time I run it, it should give us another thing back. See, Vencabot, SepTV, Vencabot, Dicksucker, Vencabot. Vencabot. Boy, it seems to favor Vencabot and Sep and Dix. There's a lot of guys entered in there, right? Dix, Zanzu, Vencabot. Oh, there's not really that many guys. Okay, well, that's fine. Dix says spaghetti. If I put that on a piece of bread and add cheese, does it count as a pizza? Spaghetti. A piece of bread and add cheese. Is that a pizza? I'd accept it, Dix. I'd accept it. Hell yeah, I'd accept it. That's pizza. I'd eat that. If you said, here's some pizza, I wouldn't be like, that's not pizza. I'd be like, yo, I'll eat that shit. So we're getting a random key in return, right? So basically that's what we're doing here. Let's go ahead and use this code now for our Pokemon example. So we know we want to use a random move. We gotta get this random move name though, right? We want to get a random move name. Well, here's how we're going to do it. We're going to say random move name. I know, it's kind of annoying, right? This is the default colors though, built into idle. Random move name equals, it's a list. No, we're going to say a random dot choice from the list of our Pokemon 2's move dict dot keys. Right. So we're saying here is, get the keys of our Pokemon's move dictionary, then turn that from a view into a list, and then from that list, pick a random choice. In fact, I think it's kind of complex for one line here for beginners. Let's break it up into multiple lines. It'll do the same exact thing, but we're going to make it a little more clear how it's working. So we're going to say, view of, move names equals Pokemon2.moveDict.keys. Then we're going to say, list of move names equals list from the view of move names. Then we're going to say, random move name is a random choice from our list of move names. And there you go. Now our opponent uses a move at random. What if it crashed slices of cheese? Dix, you're pushing it, man. You're pushing it. So you got a slice of bread, then some spaghetti, and then cheese on top. Yeah, that's still pizza, even if it's Kraft. I would destroy that. I would eat the fuck out of that. Okay, cool. There you go. So now we have this code that picks a random move. What if it's Wonder Bread? Wonder Bread? Yes. Barely. Wonder Bread with spaghetti on top and cheese. You would definitely need to have something to hold it up. You need to have something to hold it up, otherwise it would fall apart. But yeah. You probably need to make it in your... You need to put the bread in your hand and then put the spaghetti and cheese on top. Because it would fall apart for sure. But yes, I would eat the fuck out of that. Alright, so now we have this, a random move our Pokemon uses. So again, our old code was way more complex than this. On our our day 2 code, this is way easier to understand. Right? It's just you get a move name from the user, then you try and use that move name. If you don't have that move, print off an error message. And the Pokemon uses a random move. It's much shorter. Right? Our old code was literally like more than 100 lines. This code is like 10 lines long, right here. But what's interesting about that is that we've have that complexity from before, but we've used classes to sort of put it behind a barrier, right? We can write this code once, it's very complex, and then never read it again, right? We can just use the simpler code to access things now. That's a big part of what classes are all about, is making your program more human readable by putting complexity behind this sort of veil, or disguising the complexity, right? I'm going to lower down about the song, guys. This music is my friend Aubdat's music. That's A-U-B-D-A-T. This is his one song that's very resonant. It's kind of louder than the rest. Okay, let's fight. So now our opponent should randomly comb his hair, just like me. Let's see if Dix will randomly comb his hair now. What move should he use? I'll use Tackle. Hey, he combed his hair. Nice. Let's use Tackle again. What move should Zanzu use? So Dix combed his hair twice. I'm going to tackle him. Now he tackled me back. You never combed your hair ever, Dix? Well, let's get rid of that move from your list then. I'm sorry. I thought that you were a hair comber. Oh, we can't because all cyndaquils know comb hair. Okay. Well, because it's Dix, right? Let's just say here. We're going to go down to this line of code here. We're going to say, if Pokemon 2 dot nickname is equal to Dicksucker, we'll say, just Tackle, right? Because he's never going to comb his hair ever. In fact, let's use it down here, actually. Let's go down here. And we're going to say, we get this random move name, right? We're going to say, if the random move name is equal to comb hair, then just make it Tackle. If it's Dix. So if, our Pokemon 2 dot nickname is Dicksucker, and, let's random, let's actually break this line, it's going to be kind of long. And the move name is comb hair, then just Tackle instead. That way Dix will never ever comb his hair. I finger comb it and use gel. My hair is pretty short. Use gel, huh? Finger comb it. I do that. My hair is short too. I cut my hair every once in a while. Okay, so now if it's Dix, he'll never ever tackle. My hair is longer than Venka's and thicker than molasses in the winter. Nice. Wish my hair was thick. My hair is thin and nasty. Legit, it's been about 10-15 minutes to brush it, huh? Well, it's a blessing and a curse, I'm sure. It'd be more of a curse in your eyes. Alright, so now this Pokemon's a little bit more complex now. If it's a Dicksucker, it will never ever comb its hair. Right? Because if it's comb hair, we do something else. We just tackle instead. So that's cool. Alright. So, cool beans. Our code has an actual working Pokemon battle now, right? That works pretty well. Our problem now is that we don't have a whole lot of cool moves for our Pokemon. Let's look at what our code is like right now. Let's review all the code we've written. Right? It's kind of complex, especially when you're scrolling through it the way I am with the scroll wheel. So basically, the way our code works now is that we have this class called Pokemon Move that all Pokemon moves inherit from. Right? So all Pokemon moves in the game have these attributes and these methods, at least. Right? And then we have we have two Pokemon moves that inherit from that. Right? We have this Tackle, which inherits from Pokemon Move. And Tackle actually has custom code for using it, where it actually tackles the opponent. Right? If it tests for PP first, if it has PP left, then it doesn't. Then it uses it. If not, it stops. It just says, "Hey, Tackle has no PP left. It has none left." Right? If it's empty. It prints off a message saying, so-and-so has tackled so-and-so. And then it prints off, and then it actually calculates damage based on attack and defense. And then if that damage is less than 0, it makes sure it's not any less than 0. It makes sure it's equal to 0. That way we don't get negative numbers and end up healing our opponent if their defense is too high. And then we change the opponent's HP. Right? So we actually deal the damage right here. And then finally we print off some messages here for the user, how much damage was done, how much health is remaining. And then we subtract 1 PP, because it's like an ammo count in Pokemon. So we subtract 1, we used it. And we print off how much PP is remaining for that move. And we have another move as well called Comb Hair. It's much simpler. This is Comb Hair. It's a Pokemon move. But it doesn't do any damage. Doesn't do anything, in fact. All it does is print off a message. So it prints off, so-and-so has combed their hair. We also have this Pokemon class, which defines the attributes and methods of all Pokemon. Right now, Pokemon, they always have a nickname, a monster type, an elemental type. They have HP, attack, defense, and a dictionary of moves that they can use. Right? They also have a method called use, and you use the move name on the target. That's how that method works for all Pokemon. Then we define a couple different kinds of Pokemon. They inherit from Pokemon right here. We have Cyndaquil, we have Machamps. Right? And they're both pretty much the same, except that Cyndaquil is a fire type, Machamp is fighting, and Machamp is way more powerful. He has much more HP, much more attack power, and 3 times as much defense as well than a Cyndaquil. What's the opposite? Bald? That's worried my head's lumpy, huh? Yeah, I have an ugly-ass head, so short hair would expose me. Man, you guys are so self-conscious, man. Yeah, I'd be surprised. If you guys, I don't think no one's judging anybody for their lumpy-ass head. Unless they're totally bald, in which case, yes. I'm definitely going to judge you and laugh at you. But if you have short hair or whatever, it's no big deal. Even like a buzz cut. Only if you're totally bald will I openly laugh at your lumpy-ass head. Okay, so we defined some moves, we defined some Pokemon, and now we define these Pokemon. Right here, we made 2 Pokemon, Pokemon 1 and Pokemon 2. They're both Cyndaquils with different names. And then we have this Pokemon battle right down here. Here's the Pokemon battle that actually happens. Right, cool beanzos. And then down here we have, the winner and the loser code for defining who wins and who loses. Sick. Sick. Well, you're not in a position to judge anyways. I probably do have a lumpy-ass head. I've never really seen it, though. You're probably right. I'd probably be the lumpiest head of all. I have that kind of personality, like a lumpy head personality. Alright, so, where are we at in this code? Well, I think that, to be honest, we've taught pretty much all I want to teach about classes, and methods, and functions, and conditional statements, and logical blocks. I mean, I think this is kind of the end of our journey here, at day 5, for Intro to Python. We've kind of gone through some very simple ideas and moved on to more complex ideas. We have a fully working version of Pokemon now, more or less. So really what we're going to do now is we're going to take this fully working code and look at it more like a game dev project than a teaching project. We're going to take all these things we've made and make more of them. Why don't we make some more moves? Why don't we make some more Pokemon, right? If we have another half an hour left on the stream, we might as well while we're here. So, first of all, we have these Pokemon moves up on the top, right? We've got Tackle and we've got Comb Hair. Why don't we make Tail Whip? Let's make Tail Whip, shall we? Well, wait. Okay, so a Comb Hair only has 1 PP, right? And right now, it doesn't ever reduce its PP. Let's fix that right now. Let's fix it so we say, when we use the move, we subtract from the PP. So we're going to say, self.current PP equals self.current PP minus 1. There you go. So whenever we use this move now, it reduces PP. But also, we're going to add the same line of code from up here from Tackle, where when we try and use it, it says, Tackle has no remaining PP. If it has none, right? Let's try that. Let's just say right here. If self.current PP is 0, if we have none left, then print off, Comb Hair has no remaining PP, and then all that it does is it returns, right? It ends the function. This never happens, right? It just returns nothing. It just ends the function. Okay, well, we have a problem with that. Let's fix this bug essentially first. before we move on to making more moves. All right, let's run this code now. Let's have him comb his hair. Now Zanzu comb his hair. Okay, so we combed his hair. That's great. Let's comb his hair right now. Comb his hair again. Now, what's going to happen, guys? It only has 1 PP, this move, right? We just used it. Now it has 0. What's going to happen now? Okay, well, it says comb hair has no remaining PP, and then he gets bodied by dicks. He gets tackled. Right? Now, in actual Pokemon, you would be prompted to pick another move. You wouldn't use up your turn on a move that has no PP left. Right? But right now what happens is it prints off a message, and then he gets tackled by dicks. How are we going to fix that? How are we going to fix that, guys? Well, I'll tell you how. We're going to, when we try to use a move that has no PP, we're going to raise an error. Let's talk about the raise statement. Right? So we talked about, return, we talked about all kinds of cool statements like continue, but there's another statement. It's called raise. Now, what raising does is it forces an error that will crash your program. It forces that to happen. So let's go do an example real quick. All right. In our exceptions example. So let's make a, let's just go right here and just raise out of nowhere. Let's just raise right here. So we defined our dictionary. Let's actually get rid of random. We don't need random anymore. We have our dictionary here. Very simple. And we're going to just raise. That's it. End of the program. Done. Raise. Then we're going to go down here and we're going to say, print, hey, we're still alive. Right. Let's see what happens if I run this code. Boom. Right. I'm sorry, apparently you can only use raise if you're inside a try loop. Let me clarify that, guys. I'm sorry, that was my mistake. So raise as a statement can only be used inside of a try except block. We talked before about try and accept, right? So let's talk about try and accept. Let's try, to print off our dict, Bloody Angels 67. Now we learned before it's a key error, right? Because there is no key by that name in this dictionary. So we're going to accept that. So we're going to say, print, we accepted an error. Right? And because we accepted it, we're still alive. Let's run this code here. Okay, so we tried to get this item from this dictionary that does not exist. It raised a key error, but we put in a try block. So even though it raised a fatal error, we made it not so fatal because we accepted it right here. Right? But what we can do is we can actually accept the error, and then we can use the raise statement to revive it. Right? We killed the error, and now we can resurrect it using a raise. Now there are situations where you want to do that in, right? Where you'd want to print off a message like we got an error, and then you still want your program to crash. That way you know to fix it, right? You don't want to forget to fix it. So print off a message. Hey, listen, we stopped this error from happening, but also we're going to crash your program. Now let's run this now. Yeah, see, so we print off this message. Hey, we accepted an error. Oops, but we re-raised it. There's the key error right there. In fact, it crashed our program for us. We used a raise statement. Are we even truly alive? I think we are, Zanzu, yeah. I feel like I'm alive right now. Maybe it's an illusion, though. I don't know. Could be wrong. But here's another thing we can do with raise, right? We can raise an error in an accept block, right? We can re-raise it that way. Or we can raise an error that we want whenever, right? I think. Let me see. I'm not totally sure about that. Let me test that real quick. I think I can raise a key error, for instance, right? I can supply like a key. I think I can do that. Let's see what happens. Yeah, okay, see, so what I've done here is I wanted to raise a certain kind of error, and I can give it an argument. All kinds of errors have arguments, right? In the case of key error, you give it the bad key, right? The key that you can't find, right? All right, so even though this error didn't actually happen organically, right? It didn't happen organically, I can still force it to happen, right? But in fact, I can even supply some messages that might be kind of, hypothetically speaking, a little bit deceptive, like KeyError Vencabot. Even though Vencabot is in that dictionary, right? I can still raise an error there. You would never do this, of course, in real programming, but I'm just saying that you can feed it whatever you want, right? You can raise an error, you can make it happen, even if that error didn't really happen. Now, why is that important? Well, because we can define our own kinds of errors and do all kinds of fucking crazy ass shit with them, dude. It's sick. Watch. I'm gonna make a new class. I'm gonna call it, Vencabot error. And I'm gonna inherit from exception, right? Very simple. There's no code in there. It's just pass. All it does is pass. There's nothing about Vencabot error that is different from a generic ass exception. It's just a generic exception. However, because it's called Vencabot error, because we're giving it a new name, we can use it in some cool fucking ways. Like, watch. We can say, watch this. I'm gonna make a new code here. We're gonna say, Vencabot is cool, and that's false. He's not that cool, to be honest. He's all right at best. He's not really like cool. Then we're gonna say, if Vencabot is cool, then print, fuck yeah, I'm cool. Right? Obviously. But if Vencabot is not cool, we're gonna crash our program. We're gonna raise Vencabot error. Right? Let's see if this works. I might need to have parentheses there. I'm not sure if I do or not. No, it's fine. We don't need to. Cool. So here's what happened, guys. A Vencabot error is an error that we just made up that happens if Vencabot's not cool. Right? So in the case of a key error, it happens if we try to get a key out of a dictionary that does not exist in that dictionary. We learned about name error earlier. We get a name error if we try to use a function that we haven't defined yet. Or if we try to use a variable we haven't defined yet. They're both name errors. But we can define our own kinds of errors. So in this case, we have an error that happens if Vencabot is not cool. Right? Now, that's kind of interesting, but that's not really... How do you apply that in real code? Right? You can make your own kinds of errors. That's kind of fun. Right? You can catch them. You can raise them. But what's cool about making your own kinds of errors is that now you can catch those errors and deal with them in customized ways. I know that sounds kind of esoteric. Let's look at an actual practical example. We talked before about this PP problem, right? I have a PP problem in real life, but we have this thing here that says, tackle has no PP remaining, and if we have this problem, we return, right? We end the code, but all that happens is then Dix gets a turn, right? Hey, what's up, machine? Hey, thanks for the raid, little tank. How you guys doing? Welcome back, Faust. So let's, instead of just returning when we don't have PP, let's do something else. Let's actually make a new kind of error. Let's make a PP error, right? And we're gonna inherit from exception, and then we're gonna pass because it is the same way. It is the same as exception in every way, except as a different name, right? So it is just a very generic error you could have, except that it's called PP error. Otherwise, it's the same, right? So the name is all different. It's all different, right? That's what pass means. Pass means we're not overriding anything from our parent. It inherits everything from exception, and nothing else has changed. That's great. But now we can raise it down here. So instead of returning, we can raise PP error. Okay? That's fucking sick. That's fucking sick. In fact, why don't we make our error a little bit more interesting? Let's actually override a init. And we're going to say, no, that's not. That's too complex for now. We'll talk about that later. Let's just have it pass for now. I think my PP doesn't work. We're still making game codes. Yeah, still making game codes. It's so hard to get it back up after it goes down. Wow. Latest Viagra patch. Wow. Okay, so we have this new error we made called PP error, right? And this is going to always be raised if you try to use a move that has no PP left. So we're going to say, print off a message here, has no remaining PP, and then erase the error. And same here. Right. Down here, it says it has no remaining PP. We're going to erase PP error. Right. So now this is going to crash our code. Because as you have to recall, if you raise an exception, it crashes your code. So let's try this now. Right, let's just run this code. I want to use comb here. Oh, I'm sorry, I fucked it up. It's a key error. Comb here, key error. Bloody angels. Well, is that correct? I think it's trying to run more than one piece of code, to be honest. Comb here. There it goes. Yes, that's a bug with idle. No big deal. Okay, so we tried to comb his hair there. And now he has no PP left. Right? So what if I try and comb hair again? It's going to crash our code, right? Boom. PP error. It crashed our code with PP error. That's cool. But now we can catch that error and use it to our advantage. Damn it. So let's go down here. And we're going to say, except key error, then doesn't know that move. But how about we also accept PP error and then continue. Try again. Right. In fact, because we are accepting the error right here, we're going to say, we can print Pokemon1.nickname plus, let's just say, we can just say user input plus has no remaining PP, right? So that's true of any move that has a PP error. So we can actually get rid of this code from here. We actually don't have to say that here anymore. Not here, nor here. So basically now, if the move has no PP left, it raises PP error. Right? And if we catch that error, we print off a message saying there's no PP left, and then we go back to the top and ask again for a move. Oh my god, we're legends. That Python. What's up, Ryan? Welcome aboard, dude. Alright, so let's run this code now. So now we can comb our hair. Over here, actually. Comb hair. Okay, I'm gonna try combing my hair again. Hey, look at that. See, it says no remaining PP left, and I get asked again for what move I want to use. Right, so instead of just being punished for typing in the wrong word, let's say that I didn't know my PP was out for comb hair. I hate not knowing my PP is out. I had that problem back in when I was working with my fly. Now instead of being tackled by dicks, we instead get asked again what move to use. Am scary, Python, it do a bite, much constrict. Fucking Python. Cool ass shit. So our program is working really, really well now. And again, thanks to the concepts that we've learned that seem very complex at first, I'm sure to some of you guys it still seems very complex. As you use them more, they'll become more familiar to you. We have made our code simpler. Right? We have used more complex ideas and then hidden them away so that you only see the simpler part. Right? It's very simple now. It just says, try to use a move. If you don't have that move, print off you don't know that move. If it's out of PP, print it has no PP, and then do the opponent's turn, and that's it, you're done. Whereas before, it was all one huge line, one huge block of complex code. Now it's one small block of simple code with the complexity hid elsewhere. The complexity is hid around up here. So I'm trying to use, I'm now using Python 3. I'm living in the future where the special formatted strings, oh my god, Ryan, this is the best part of Python 3, is the F strings, oh my god. I've been using Python 3 for a while. I think F strings are pretty new. Even they're kind of new, even for Python 3. So Kenny, you didn't know about making your own exceptions and how to use them? It's pretty sick. It's a really good way to communicate in your code. You can make your own kinds of errors, and then raise those errors, and then you can accept those errors to deal with your code elsewhere. Deal with that kind of stuff. How you doing, here goes? Okay, so now our program works as well as it used to, right? Except that we had more moves back in the day. We actually knew more moves back then. We knew, tail whip and growl and that kind of thing, and flamethrower and stuff, and Tatsumaki Senpuken. Nowadays we only know tackle and comb hair. But essentially, our code is much tidier on a courtesy of classes. And it is much more flexible. We can much more easily add new moves. Again, back here, let's go look at our day 2 code. Back before we knew classes, right? It's before we knew classes, how they worked. Adding new moves was a huge pain in the ass, because every time you wanted to add a new move to a Pokemon's potential library, you had to type it in manually, like in this big block. And for that reason, we have like all this redundant code down here, right? Pokemon 2's code is very similar to Pokemon 1's code, but it's for the second Pokemon, so we had to type it in again, which kind of sucks. Now that we have classes, we can very easily manufacture moves, at a massive scale. We can easily manufacture new Pokemon, and then use them in the same kind of situations together, because it's always the same situations for Pokemon, right? They always fight each other and kill each other, and it's real sad and everything, but that's just life for a Pokemon. And now we can kind of assume that they're going to always do the same stuff and just easily swap them in and out, courtesy of these cool classes and their attributes and their methods. So Ryan says, those Game Boy devs would have been spoiled rotten if they had Python instead of ASM. Yeah, you're right. Well, I mean, did they really program Pokemon in assembly, you think, Ryan, at that time? I assume they had some kind of language they used, some kind of dev kit they used for the Game Boy that let them type in human readable code. Now do team battles. Maybe a 6v6 MOBA, huh? Did you see Nintendo won their lawsuit against ROM sites? No, I didn't see that. Here it goes. That kind of sucks. I hope this is not a dev kit. Fisher was awesome. C is very slow for NES. Yeah, this would be a Game Boy, but same diff. It's an 8-bit console. A PvP-oriented MMO. Oh, we'll do that at a future date. As you guys know, I love writing network code, like our old Battleship game dev. We'll make a multiplayer Pokemon someday, if you guys are interested, that is. If you guys want to do that one day. But yeah, so our code here is pretty complete. I'm very proud of it. Again, we could add more moves and stuff in the future, and I think that we probably will. I'll probably do, I don't know. We probably will do one more Intro to Python next week on Friday, where we still do a day 6 of this code here. All we're going to do is do some game dev. We'll review some concepts, but we've really covered everything I wanted to cover, right, in Intro to Python. So the series will continue, guys, but it's going to continue from the start again. We're going to go back to the beginning and look at the basics again, and then work our way back up here again repeatedly as a way to review things. But I think we're going to do one more stream of this program and just make it a little bit tidier, make some more moves, some more Pokemon, and we will make it work better next time, even though I feel like we've really kind of covered all the basics I wanted to cover here. But yeah, come back next week, guys, for even more Intro to Python, more Pokemon, and then the following week we're going to start a brand new project, going back to the very, very, very basics. If you guys have trouble understanding this, come back a couple weeks. We'll be going right back to the very beginning. Guys, as usual, if you enjoy hanging out, want to keep the channel online, check out my Patreon page at patreon.com/Vencabot. Even $1 a month is a huge help, guys. Helps me buy groceries and gas and all kinds of good stuff like that. I stream for 40 hours a week every week, and when the stream ends, I'm going to stream all night long. It's kind of like my whole life here, and thanks to the support on Patreon, as it grows, I hope I'll be able to kind of do this as a more long-term thing. Right now, it's looking kind of grim in terms of the longevity of the project, because we're not making a whole lot of scratch through Patreon. Likewise, Twitch subs are great. They're very helpful. They're not quite as good as Patreon. Twitch takes half of the Twitch sub. A $5 Twitch sub is worth $2.50 to me and $2.50 to Twitch. On Patreon, it's more like a 90% kind of deal, which is kind of nice. But if you have Amazon Prime or Twitch Prime, do not forget, guys, you get a free sub every month. That's very helpful around here. It does not auto-renew. You have to renew it manually, which is kind of a drag. That's why we lose a lot of subs that way. People don't really remember us here. Boo-boo-hoo. Boo-boo-boo-hoo-hoo-hoo. Also, we're on YouTube, guys, at youtube.com/Vencabot Archive. You can go watch more Intro to Python there. Go watch some gameplay. We have more than 1,000 videos. Believe it or not, each one about 2 hours long and fully commentated. There's I think 7 episodes of Intro to Python over there right now, which is kind of nice. It's all of our codes on GitHub, by the way, at github.com/Vencabot/intro_to_Python. That's kind of nice. If you go to the YouTube channel, you can find them there on YouTube. There's a link to the GitHub. If you're like me, you enjoy the channel, but not exactly rolling in dough, right? Maybe you'd want to help for free in that case. Get in the chat, come say hi. That's a really great way to help out. Welcome aboard, Yig. Guile hurt itself in its confusion. You guys in the chat make it so much more fun for me to stream here. If not for you guys, I definitely would not be doing this. So that's the best way to help out the channel, is to come say hi and hang out in the chat. Also, you can help for free by following on Twitch if you're not already following. Tell your friends we're here, and save clips of funny stuff, scary stuff, salty stuff. Mostly for gameplay, not really for programming, but the clips are really cool for my break screen when I go on break and get some food. Also, they're good for your sharing on Facebook and Twitter to promote the channel, and on our Discord server at Vencabot.com. I'm going to go on a very short break, guys. Come right back with some pizza and cartoons. It's a special event on Friday, pizza and cartoons. We're going to watch some Casper the Friendly Ghost and eat some pizza together. It's going to be kind of cool. I will see you guys in a few minutes. Just make Neopets, huh? Or Maple Story. Yeah, you're right. I could never make Maple Story. Welcome aboard, Panders. You're almost in time for pizza, man. It'll be ready in probably about 10-15 minutes. We're going to do one more complex episode, guys, of Intro to Python next Friday. And then we're going to revert. We're going to revert back to the very, very basics, starting on the following Friday. Let's go, Zanzu. Let's go, Panders. We're going to have some din-din, dude. I ordered the pizza already, Zanzu. I ordered the pizza already. Hopefully the pizza bread is not, like, diabolical this time. Remember last time I had that fucking bite of that pizza bread and it, like, fucking demolished me? I thought it was cursed.
I just one-shot her with the crusher.
I thought it was possessed by a demon. Let's go, Dix. Get that Wonder Bread, homie. Yeah, Wonder Bread is a brand name. I think Zon probably knows what it is. It's some really terrible-ass white bread. Cauliflower crust instead of bread? That's kind of what it was, Ryan. I had Hungry Howie's, and I took a bite of this one piece of the bread, and it was, I think what had happened was they had spilled some garlic sauce on the oven, and it had burned onto the bottom of this piece of bread, and so my tongue touched it on the underside, of course. And it was like such a repulsive taste.
Shit, man.
I love garlic.
Fucking Oro,
but
dude.
it was like burned garlic sauce or something like that. Oh, it was so nasty. I thought it was poisoned. Only later did I figure out when I ate it cold the next day that it was just fucking garlic. It wasn't anything super dangerous. It was just fucking garlic. But it was like an insane amount of garlic, like burned on. It was fucking gross.
No arguments for that taunt. That was just me popping off.
I was gonna
that
die,
was so fucking
dude.
sick.
70% cauliflower. Tastes like regular pizza, but it crumbles when you chew instead of acts doughy. Huh. Well, that sounds like something I probably wouldn't enjoy, but I might be surprised. The doughiness is so clutch, though. The doughiness is so clutch. That's what I'm saying, Dix, yeah. Just like some bears.